Till now we have completed our module 1, module 2, module 3, module 4 and module 6. Today we will see module number 5, which is numerical differentiation and integration. In this we have the trapezoidal rule, the Simpson rules and other rhombus rules, with the help of which we are going to solve integration. So in the numerical integration you will be given a function and you need to integrate that function within the limit a and b, where b is your upper limit, a is your lower limit. So between this upper and lower limit you have to integrate. Now you have to determine a parameter called h, which is basically the range which you have. That is, a is your minimum, is the minimum, and b is the maximum, So this difference, this b minus a difference, you will be dividing that into a number of parts called n. Now depending upon that n, you will have your h. Suppose your b is 4 and your a, which is the minimum term, is equals to 0. Then what is your b minus a? B minus a is 4. Now if I want to divide into 4 parts, then I will be dividing it in b minus a divided by 4. That is 4 by 4, so it's part of 1. So the first value is 0, second will be 1, then 2, then 3, then 4. So it's divided into 4 parts. If I wanted to divide it into 2 parts, then I will be dividing it with 2. In that case, to reach from 0 to 4, what is the next step? It is 0 plus 2. So you will be having the next term 2, then you will have 4. We have already seen it, isn't it? These things we have already seen. So if this is your first term, the next term will be x0 plus h. The x2 will be basically x1 plus h. This x0 plus 2h. So depending upon what is your n, you have different methods. Now there are many rules which is available. We have the trapezoidal rule, the Simpson 1/3 rule, the Simpson 3/8 rule, the Weddle's rule, the rhombus method. Now these rules are basically derived from the parent formula, which is the Newton-Scottish formula. In the Newton-Scottish formula, this n, based on how you determine the n, what value of n you are taking, we have these methods. Various methods. Now let's see them one by one. If you select n is equals to 1, in that case you will be using the trapezoidal rule. You will be getting this formula. Now if you want to integrate your function within the limits of x0 and xn, that is the minimum and the upper limit, then the formula is h by 2 y0 plus yn plus 2 y1 plus y2 yn plus 1. Now this trapezoidal formula, it can be used for any value of n. Next we have the Simpson's 1/3 formula. Now if I put n is equals to 2 or n is a multiple of 2, in that case we will be using the Simpson's 1/3 rule. In the Simpson's 1/3 rule, in order to calculate the integration, you will be using this formula. Similarly, for Simpson's 3/8 rule, we have n is equals to 3, or it is a multiple of 3. N should be a multiple of 3, either 3 or multiple of 3. In that case, we will be using this formula. We will see an example how to use it, so don't worry about that. In the Weddle's rule, you are going to select your n is equals to 6. In that case, n has to be a multiple of 6, or it can be 6. In that case, you have this formula. Now there is an alternate formula for the Weddle's rule, which is this. This is the alternate formula. Now as you can see, there is a pattern in this formula. See, y0 5y1 plus y2 plus 6y3 plus y4 plus 5y5 and y6. Then this has been again repeated in a different form. See, we are writing 5y6. Now 5 is still here. Then we have next term, which is y7. Then we have y8. Then the 6 is over here. Then we have y9. 4, we have made it from 9 to 4, as it is 3 to 4. Here we have 9 to 10. Then 5. See, then we have 5. See here, since we had y6 over here, we started again with y6. Similarly, since we have y12 over here, we start again with y12. So there is a pattern. Now let's see an example. Suppose we have given you a problem where you need to integrate from 0 to 6, and your function is 1 by 1 plus x square dx. Now in the question you will be either given a particular name of the formula by which you need to do it, or you will be asked to do it anyway. Now if you are given an option to use any method, then depending upon, I will suggest you, depending on the time left, to select your n, because if you increase your n, the number of steps required will be more. So if your n is more, the number of steps required is more. Accuracy is also more. If its n is less, then in that case the accuracy is less, then the result will be quicker. So in this particular example, since I have not given you any method, you can use any method. So I am selecting n is equals to 6. Now why I am selecting n is equals to 6 is that if I select n is equals to 6, then what happens is that I can use all the formulas and show you how the formulas work. Because over here this trapezoidal rule can be used for any value of n. So n is equals to 6 also, this method can be used. Now this Simpson's one-third rule, it has to be a multiple of 2. So 2 into 3 is also 6. So this also satisfies. Then Simpson's 3/8 rule, it has a multiple of 3. 3 into 2. So this is also satisfied. And Weddle's rule, so n has to be 6 or multiple of 6. And here it is 6 only. So see, n is equals to 6. Now 6 n is equals to 6. What is your h? H is your b minus a divided by n, which is 6. So 6 minus 0 divided by 6, which is equals to 1. Hence your first term, which is your x naught, as you can see, this is your first term, which is your x naught, which is equals to 0. And what is your y? Your y is this 1 divided by 1 plus this term is your y. See, this is your y. So just put the value of xn in your y and you will have your y naught. Then what is your x1? X1 is x naught plus h. X naught is 0. And what is your h? H is 1. So we have 1 to 1. So x1 is 1. Since x1 is 1, what is your y1? Just put it on the formula 1 by 1. This way you will be calculating up to y6. Please pay attention that I have made a mistake over here. This is not y4, it is x4. It is x4. It is x5 and it is x6. Okay. Correspondingly you have your y4, y5, y6. Now since you have all the values present with you, you can now use trapezoidal method to calculate. What is the formula? As you can see, it is over here. The trapezoidal formula is this, isn't it? It was the formula. You have all the parameters available with you, which you have calculated. See, these parameters are already known to you: y0, y1, y2, y3, y4, y5. Everything is known to you. All these values are known to you. H is known to you. Just put the values and you can calculate your in this integration with the help of trapezoidal rule. Similarly, for Simpson's one-third also, if you know this formula, you can just replace the value from this data over here and you can calculate. Yes. Similarly, for 3/8 rule also you can. For Weddle's rule also you can. So this is very easy numerical solution. All you have to do is that you have to remember or understand the formulas. If you know the formulas, then you can easily calculate the integration. It is very easy. You have to select your n. Based upon your n, you are going to use the formula. In this particular example, I have used all the method. In the examination, you will not be using it. You will be using any one of the methods, or you will be using the method that the examiner is going to ask you. Now if you directly integrate it in the original way, in the original true way, then 1 plus this integration of the x by 1 plus x is basically tan inverse of x, and if you put the values, you will basically find the value to be 1.05, and the value which you have calculated is also nearby only. See, 1.4. If you find the approximation is 1.4, it is also 1.4, it is also 1.4, it is also 1.4 only, and the value which is original value is also 1.4. So these methods give you approximate value. So with the help of that, we have already completed this, isn't it? Thank you.